Welcome back. In our last lesson, we discussed how to work with percentages and decimals. In this lesson, we will discuss how to make more complex calculations involving percentages, which is a skill commonly assessed in QR. By the end of this lesson, you should be able to describe how to change a value by a percentage, describe how to calculate percentage change, describe how to find the original number, and list common mistakes when working with percentages. In QR, you'll find percentages used in many questions. Recall that a percentage is a useful way to compare two proportions in a numerical fashion. We will discuss the following skills for working with percentages: changing a value by a percentage, calculating percentage change, and finding the original number. We will discuss each skill in detail. Let's begin by discussing how to change a value by a percentage. A common calculation that you'll need to make in QR is increasing or decreasing a given value by a percentage. Let's first discuss how to increase a value by a percentage. To increase a value by a percentage, most people would use this formula. New value equals original value plus percentage expressed as a decimal times original value. Let's illustrate this with an example. Just say we want to increase 2.2 by 10%. We should first convert 10% to a decimal, which will be 0.1. Our equation will be 2.2 plus 0.1 times 2.2, which is equal to 2.2 plus 0.22, which is equal to 2.42. However, a shortcut is available for calculating a new value after being increased or decreased by a percentage. If we want to calculate 10% higher than value y, this is equivalent to 1y plus 0.1y, which is the same as 1.1y. We can therefore simply multiply our original value by 1.1 and we can obtain the answer in one step. This saves time and is less likely to result in errors. We can express this shortcut with a new formula, which is new value equals original value times 1 plus percentage increase expressed as a decimal. Let's try it out using the same example as before. To increase 2.2 by 10%, we simply multiply 2.2 by 1.1, which gives 2.42. Similarly, if we wanted to increase a value by 258%, we would multiply it by 3.58. Now let's discuss decreasing a value by a percentage. We can use the reverse of the shortcut formula we have just covered. New value equals original value times 1 minus percentage decrease expressed as a decimal. Let's apply it to an example. If the price of petrol was $2 a litre and it decreased by 20%, what would be the new price of petrol? To calculate this, we multiply the original price by 1 minus 0.2, which is 0.8. $2 times 0.8 is 1.6, which makes the answer $1.60. As another example, if we wanted to calculate 12% less of a certain value, we would multiply it by 1 minus 0.12, which is 0.88. Now let's discuss percentage change questions, which are common in QR. In these questions, we are provided with a value of an item before and after a change, and we're asked to calculate the percentage change. The formula for percentage change is difference, new minus original, over original, times 100. To calculate the percentage change, you first need to work out the difference between the two numbers you are comparing. You then need to divide this by the original number and multiply by 100. Let's consider a simple example. The price of a watermelon is $6 and it is on sale this week for $5. What is the percentage change? Using our equation above, the difference is $1 and the original cost is $6. Therefore, 1 over 6 times 100 equals a 16.66% change. Some QR questions will require you to calculate the original number after a percentage increase or decrease. You can use this formula. Original equals new over 1 minus percentage change expressed as a decimal. Let's use this equation to solve a simple question. If a pair of shoes were purchased for £50 when they were on sale at 60% off, what was the original price of the shoes? Using our equation, original equals new over 1 minus percentage change expressed as a decimal, we get 50 over 1 minus 0.6, which is equal to 50 over zero point 0.4, which is equal to £125. It can be difficult to remember the equations and manipulations for changing a value by a percentage change, and finding the original number. To make it easier to remember these equations, you can use a percentage change triangle. This involves using the three variables of interest, which are the new number, the original number, and the multiplier. The multiplier is simply the decimal form of the percentage change. To use the triangle, simply cover the variable you want to calculate, and the equation is formed by the remaining two variables. Using our triangle, if we want to find the new value, we multiply the original by the multiplier. If we want to find the original value, we divide the new by the multiplier. If we want to find the multiplier, or percentage change, we divide the new by the original. Let's consider an example to see how this triangle works. Let's say the price of milk was $2.20 last year and increased to $2.64 this year. We want to find the increase in price expressed as a percentage. Here, the original is 2.2, the new is 2.64, and the multiplier is the unknown, or what we're trying to work out. So if we call the unknown multiplier y, the equation becomes 2.2 equals 2.64 divided by y. Rearranging the equation, we get 2.2y equals 2.64, and finally y equals 2.64 over 2.2, so y equals 1.2. Expressed as a percentage, this is 1.2 times 100, or 120%. As this is 20% more than our original of 100%, the percentage change is 20%. Let's now use our triangle to find the original number. We'll consider the same example expressed in a different way. Say the price of milk this year is $2.64 and the increase from last year was 20%. We want to find last year's price. The new price is 2.64, The multiplier is 1.2, and the original price is the unknown, which we'll call y. Using our triangle, the equation will be y equals 2.64 over 1.2, so y equals 2.2. Therefore, last year's price was $2.20. It's common for students to make errors when working with percentages in QR. Common errors include not understanding what you need to calculate, creating the wrong equation, and not establishing the correct multiplier. Let's consider each error in turn. Firstly, it's important to understand what the question is asking and what you need to calculate. For example, are you being asked to calculate the original number, the new number, or the percentage change? If you're not clear on what you need to calculate, it's difficult to form the correct equation. Another common error when calculating percentage change is to form the wrong equation. When calculating percentage change, students commonly make the mistake of dividing the difference by the new value instead of the original value, or dividing the original value by the difference. Let's take an example. A country's population is 35 million this year. Next year, it is expected to be 37 million. What is the expected growth in population expressed as a percentage? The difference in population is 2 million people, and we're considering a percentage increase. Remember our percentage change equation. Percentage change equals difference over original number times 100. In this case, we have to divide the difference of 2 million by the original number of 35 million, so the equation is 2 over 35 times 100, not 2 over 37 times 100, which is a common mistake. Another common mistake is to divide the original value by the difference. This mistake would lead us to forming the equation 35 divided by 2 times 100 rather than 2 divided by 35 times 100. Remember when calculating percentage change to always divide by the original value. To make it easier to identify which value to use, you can follow this rule of thumb. If you are asked for a percentage decrease or saving, the larger number should be the original value. If you're asked for a percentage increase, the smaller number should be the original value. This rule can help you avoid making mistakes when calculating percentage change. Using the percentage change triangle will also help you avoid this error. Our final common error is not establishing the correct multiplier or percentage change when calculating the new or original number. When there is a percentage increase, the multiplier equals 1 plus percentage change expressed as a decimal. When there is a percentage decrease, the multiplier equals 1 minus percentage change expressed as a decimal. Let's look at an example. If a shirt is for sale at 25% off and the discounted price is £80, what is the normal price? A common mistake would be to calculate 25% of £80, which is £20, and add it to the sale price of £80 to get £100. However, this is incorrect. Instead, first work out our multiplier. 25% off means that the percentage change is 0.25. So our multiplier should be 1 minus 0.25 or 0.75. We want to find the original price, which we will call y, so our equation using the percentage change triangle is original equals new over multiplier. So y equals £80 over 0.75, which is equal to 106.67 pounds. Well done for completing this lesson on working with percentages. Hopefully, you now have an understanding of how to make calculations involving percentages, which are common in QR. We covered some important formula that you may wish to note down or memorise. They include percentage increase multiplier is 1 plus percentage change expressed as a decimal. Percentage decrease multiplier is 1 minus percentage change expressed as a decimal. Changing the value by a percentage is new value equals original value times multiplier. Percentage change is difference, which is new minus original, over original times 100. Finding the original number is original equals new divided by multiplier. The percentage change triangle is very helpful to remember these equations. In our next lesson, we will discuss ratios and proportions, which are other important concepts to understand to succeed in QR. See you there soon.